Welcome to erctipsknowlogy. In this video, we will be learning about nodal analysis using three resistors connected in series parallel with two voltage sources. So, let's start. The first thing that you have to do if you have a problem like a circuit with two voltage sources is to analyze them as to which method may we use. But in this particular problem, we are asked to find the current in R2 using nodal analysis. Therefore, we have no choice but to use nodal analysis. In nodal analysis, we need to identify the node. For example, let's use VA or node VA. And let's make all currents I1, I2, and I3 to go out or come out from this node VA. And the directions of the currents will also be going out or coming outward from the VA. So, we have I1, I2, and I3 all pointing outward, and we will assume this only, and if we will get a negative answer later on, then that would mean that our direction is wrong. Anyway, we have here I1 plus I2 plus I3 equals 0, and this is like Kirchhoff's current law, and we can get I1 by Ohm's law, V1 over R1 plus V2 over R2 for the I2 and V3 over R3 to get I3. All of them equals 0. And then from V1 we will use node analysis where we will just follow the current, and from the figure you will see that I'm actually pointing to the left with I1, therefore V1 will be VA minus the positive of 7, and that would be VA minus 7. And then going on V2, that will be VA minus 0, and we have the ground over here. Let's put 0 volts for all of this. So VA minus 0 will be for V2, and for V3 it would be VA minus the positive 14 or VA minus 14. And there you go, that's how we do it. And let's substitute the resistors with its values in ohms. So for R1, we got 1K or 1000 ohms. For R2, we have 500 ohms. And for R3, we have 900 ohms. So we have 1000 ohms for R1, 500 ohms for R2, and 900 ohms for R3. And then we will be separating the VA minus 7 over 100 into 2, and that would be VA over 1000 minus 7 over 1000. And also with the VA minus 0, let's separate them with a common value for the denominator of 500, and the VA minus 14 will be separated also with VA over 900 and 14 over 900. Now you will see here that I put minus, and when we have a positive and negative signs, then that would be negative. If we have positive and negative over here, that would be negative or minus. So cancel the 0 because we don't need it, and the positive. Then we have VA over 1000, and we put together all fractions that has VA. So all fractions that has VA, which will be over 1000, over 500, and over 900 will be put together. And also the constants of negative 7 over 1000 and negative 14 over 900, we will put them together as well. Now, we will calculate the value of VA here by factoring out all of the fractions of VA, which is 1 over 1000, and 1 over 500, and 1 over 900. So we factor out VA, and of course we need to calculate these constants values of minus 7 over 1000 and minus 14 over 900. So using the calculator, we got here negative 7 over 1000 minus 14 over 900. And we got the answer of negative 203 over 9,000. Now the answer is negative 203 over 9,000, and we will just keep our answer as a fraction. Then it's equal to 0, and let's calculate for the sum of the three values of VA, which is 1 over 1000 plus 1 over 500 plus 1 over 900. Now, the answer would be 37 over 9,000. Now, we got the answer of VA, which is 37 over 9,000 VA minus 203 over 9,000 equals 0. And as you can see here, we have negative 203 over 9,000. When you move it to the right, it will be positive. So let's write it again. 37 over 9,000 VA will be equal to the positive of 203 over 9,000. And we can cancel this positive now. We may or may not put the positive sign. So let's cancel it. And of course, the 37 over 9,000 over here will be under the 203 over 9,000. So that would be the denominator. So the 37 over 9,000 will be under 203 over 9,000. And let's calculate it using the calculator, the scientific calculator. Let's use the fraction over a fraction. Let's try it. Fraction over another fraction like this. 203 over 9,000 over 37 over 9,000. And of course, we will get the answer of how much? 203 over 37. Or let's change this to with decimal places, 5.486486,486. But let's use 6 digits on the fractional part or decimal part there after the decimal point. We may now use the answer as our voltage VA, and so we have V1 equals VA minus 7. V2 would be VA minus 0. We don't need to write 0, but I'll write it as well to make it clear. V2 equals VA minus 0, and V3 equals VA minus 14. And so, since we already know the VA, we may substitute VA with 5.486486 volts. And as you can see here, we will be able to get the V1, V2, and V3. Actually, right now, I already got the V2. We only need to find V2, not V1 or V3, but I might as well calculate them anyway. So we have here negative 1.5135 volts. And of course, this is the same value, 5.486486 volts. And for V3 minus 14, let's see, it will become negative. And as I have mentioned, the negative sign means that the answer is not really wrong. And later, it has something to do with the current direction, although we will not calculate that. I2 only will be calculated over here, and by Ohm's law, we got V2 over R2, and the final answer, of course, will be in amperes, because it's volts divided by ohms, but we may change it to milliampere also. So we got 0.0109729 amperes, or we can make it short like 10.973 if we want 3 decimal places on the fractional part. So this is 10.972972, but I'll make it 10.973 in the final answer in our calculation. So I2, let's write it here, 973. Okay, so we round up the answer to 10.973 milliamperes. So let's have the review or summary of how we found I2 or the current I2. So again, we first used the Kirchhoff's current law, and then we used the Ohm's law to get the I1, I2, and I3, but we still don't know V1. So we use node analysis and we look at VA, and since the currents are going outward or outside here, that will be easier to calculate. That's why we did it like that. So we found V1 by subtracting VA minus 7, VA minus 0 for I2, and VA minus 14 for I3. That's so easy, right? We don't need to think too much. It's always VA minus something, VA minus something. It's so easy. So VA minus 7, we separated them, including VA minus 0 and VA minus 14. But we have to add all of those which has a common variable of VA or term of VA, and we got this answer here, but we move the negative to the right, it becomes positive. And I also thought about using the positive negative symbol there. So as you can see here, A becomes positive B, although it's minus B, and if we are multiplying and you move it to the right, it will be divided. So we have here 37 over 9,000 multiplied with VA. It will go under the 203 over 9,000. And we got the final answer of VA. So after finding VA, we may now find V1, V2, and V3. And we did that, right? And the most important only is V2, of course. And finally, by Ohm's law, I2 equals V2 over R2, and I2 will be equal to 10.973 milliamperes, which is the same with our other techniques. So this is nodal analysis. I hope you subscribe. Please support our channel. Thank you.